So we'll now learn about loops, and first the for loop and then the while loop. And of course, it's very natural when you have a loop to have it iterate over something, and that something will often be lists. So this lesson here depends heavily on lists and understanding what lists are. So let's look at a first example. So let's first construct a list of names. So I have Goofy, Daisy, Mickey, and Donald. And then I will decide to print the last letter of each of those names. So this is how it's done in Python. Let me first run it. And then I have here Goofy's last letter is Y, Daisy's last letter is Y, Mickey's is Y, and Donald's is D. So how did that work? Well, we used a for loop, and what we did is here for n in names, so names is a list, and we ask Python to have the variable name n iterate over the objects inside of names. Okay, so names has 4 objects inside it, 4 strings, and what we do here is some sort of name binding that will change. So we bind the name n to the first, then the second, then the third, then the fourth entry in that list. And then we ask Python to do something with this. So that's where a block starts, and we ask to print n and print last letter is and print the last letter, the last entry in n. Okay, so the important thing here, it's not quite visible on this side, it's better to look first here, is that we have indented this part here, because this is part of the block that will be repeated again and again. Okay, so you have to indent with something, and you could indent with just one, but the standard is to indent with 4 spaces. And this marks a block, and you do it for everything that needs to be repeated for every n, and then you stop indenting once you have finished the block that needs repeating. Okay, so this is quite visible on the left, maybe not less on the right, but you can see how the interpreter does it. So it has 3 arrows like this where it waits for your instruction, and once it realizes that this instruction is calling for an indented block, it will replace those 3 arrows by 3 dots, and then you have to enter the spacing and this thing. And finally, to signal that you are out of the block, you should just enter an empty line in the interpreter. This is specific for the interpreter. In the regular code, you can just unindent that block. Okay, so this was one way to do an iteration. We construct a list, and then for the element in the list, we do something. Now here is a simpler way to construct a list that's more relevant for iteration, I guess. So it's range, the function range. So the function range basically asks for the list going from 0 to the argument of range, and that's if there's just one argument. If there are 2, then it will take this as a first starting point and an end point, and it will give you a range of integers. And you can even provide some spacing, like a spacing of 7, and now I have all the numbers between 0 and 70 with a spacing of 7. Okay, so this is for creating a simple list that will allow for a good iteration over this. And actually, depending on the version of Python, range might not exactly create a list, but let's ignore that for now. So here is a way to use this now. So we have range 10, which is a list, let's say, between 0 and 9, and we iterate over the elements there. And each time we have a new element, we assign the variable name n to that new object, we print it, and if n is equal to 8, we do something special. So let's run it. And we see that even though the sequence was running from 0 to 9, we've only printed things between 0 and 8. And the reason is that the special instruction when n was equal to 8 was to break. And break, what does it do? Well, it gets out of the for loop. So now we're out of it, and we don't have anything else to do. So that's it. 9 is never printed. Okay. Here is another example of how this could be useful for more mathematical things. So we're here iterating to compute a square root of 2. And we're defining an epsilon, which is 10 to the minus 10. We're taking a starting value, a float of value 1. And then we're repeating 50 times an averaging of the old x old and 2 over x old. So we are averaging x old and 2 over x old, and we're calling this x new. We're marking which iteration this is with n and then an iteration counter, and we're displaying the value of x new at this stage. And what do we do here? Well, if the value of the new x and the old x differ by less than epsilon, means there is very little change in x, then we decide to break. And otherwise, well, we replace x old by x new, and we go again through this. So what does this do? Well, this will repeat at most 50 times some averaging algorithm that should converge to the square root of 2. So let's see this in action. We start with the value of 1, and we take successive iterations, and we have now 1.5, 1.416, etc., all the way to 1.414. And now the convergence is fast enough that there is no gain in iterating anymore, at least no gain within epsilon, so we can just stop there. So if you remember, another thing we saw with for loops is that you could also use it together with an else. So let's see an example here that is actually relevant for mathematics. So what does it do here? Well, we're going to write for every n between 2 and 20, whether it's a prime or not, and if it's not a prime, we write some factorization of that number. Not all of them, but just some. So how does this work? Well, we'll iterate over all n. So all the rest should be indented, and maybe on the left you see it better, we indent the whole thing. And then for all the x's in the range 2 to n, we'll start doing something else. And what do? Well, we basically test if n is divisible by x. So if n modulo x is 0, then we write that we have found a factorization. N equals to x times n over x. And we're done with that number n. We don't need to do anything else. We can just break and go back to the next n. So we just break out of the inner 4, right? So the 4 iterating over x. Now, this will happen for every x. For every x between 2 and n, we will test whether x divides n exactly or not. And at some point, we might be done, which means we haven't found any factorization. So in this case, we do an else. We have run through all the options in the for, and we execute the else afterwards. And in this case, we haven't found a factorization, so we know n is a prime number, and we print that. And that was the end of the inside of the n loop, so now we can go and try the next n. And you see that indeed the output here is 2 is a prime number, 3 is a prime number, but 4 is equal to 2 times 2, and so on. Okay, so this was for break, and it also showed you how to use else. But you can also use continue. So continue can also be used inside a for loop. So let's see an example. So here we'll do for n in range 10. So we'll iterate over all the numbers between 0 and 9. And we'll print n, except when n is equal to 8. Then we'll skip 8 and continue. So what does that do? Well, here is the output. We see that we have not printed all the numbers between 0 and 9, except for 8 that we have skipped. So the continue, what continue does is that it doesn't exit the for loop. It just finishes that particular part of the iteration. So it goes to the next n and doesn't execute the rest of the block. Okay, so we didn't go out of the for block, sorry, but we just exited this particular iteration. So let's see another example. Let's say we want to print 1 over n for all the n's between minus 5 and 5. Obviously, we'll run in trouble when n is 0. So we'll just continue over that n. So let's see the result. I print minus 0.2 because this is 1 over minus 5, 1 over minus 4, 1 over minus 3, 1 over minus 2, 1 over minus 1. And here I should do 1 over 0, but fortunately I didn't ask Python to divide 1 over 0, which would give me a division error. So instead, I've coded beforehand, if n is equal to 0, then I should just print inf and then continue. So this continue had for consequence that I never went here for n equals 0. I just went back and took the next n equals 1, and then went on with the loop. So this is the for loop, and you see that you can use for in conjunction with break, else, and continue to do more interesting loops. To be frank, continues and breaks are very rarely used, and else is also fairly rarely used. But for is very important to do iteration, and it's one of the basic tools when programming in Python.